Hello viewers, welcome to my YouTube channel Mathematics Made Easy. Situation differential equation. Alright. So in today's video, we're going to check uh, if this following pairs of functions are linearly independent or linearly dependent. Okay. So the first question, so I'm going to solve three questions out of these. So I'm going to leave the remaining two questions for you as an exercise to try. All right. So the first question, y of 1 equals e raised to the power of ax and y2 equals e raised to the power of bx. So where a is not equal to b. So on the interval negative infinity to positive infinity. So the second question, y1 equals cos ax and y2 equals sin ax. So on the interval negative infinity to positive infinity. We have the third question, y1 is equal to a constant function which is 1 and y2 equal e raised to the power, e raised to the power of ax. So where a is not equal 0. So it's on interval negative infinity to positive infinity. We have the fourth question, y1 equals e raised to the power of ax multiplied by cos bx and y2 equals e raised to the power of ax multiplied by sin bx. Okay, so over the interval negative infinity comma positive infinity. All right, and the last question, which is y1 equals 1 over x, y2 equals to 1 over x raised to the power of 3, then over the interval 0 comma infinity. All right guys, so before we dive into the solution, please don't forget to subscribe to my channel, like my video, comment and share. All right guys, so now let's dive into the solution. Now, when does it say that a function, a given function, two given functions are linearly dependent or linearly independent? Now, let me quickly write down some things. Okay, so I'm going to say let y1 and y2 be functions. So on an interval, so we have an open interval a comma b. Okay, so if the functions are linearly dependent, okay, if the function are linearly dependent, so let me underline that, it's very important. So if the functions are linearly dependent on the given open interval, so a comma b, then the Wroskian of the given two functions y1 comma y2 will be equal to 0. So if they're linearly independent, okay, so otherwise they'll be what? Linearly independent. That is, if the Wroskian of y1 comma y2 is not equal to 0 for at least 1 point in the given open interval, so the functions are linearly independent. Okay, that's vice versa. All right, so then how do you find the Wroskian of a given functions, of the given two functions? Now, this is how you find the Wroskian. Okay, so Wroskian of y1 comma y2. So we can use the determinant method right here. Okay, so that will be equal to the determinant of this 2 by 2 matrix. That will be y1 prime, then y2 y2 prime. So we find the determinant, so this will be equal to y1 y2 prime, then minus y1 prime y2. So that is how you find the Wroskian of a given function. Okay, so let's say after finding the Wroskian of the given function, you go 0. That shows that two functions are linearly dependent. So otherwise, if you don't get 0, that shows that they are linearly independent. Do you understand what I'm saying now? Okay, so let's solve for the first three questions. All right, so let's move to the new page. So the first question that I have here, which is y1 equals e raised to the power of ax and y2 equals e raised to the power of bx. So I want to check if these two functions are linearly dependent or linearly independent. All right, so from the formula I gave you, I said if you want to find the a Wroskian of two given functions, y1, y2. So this should be the determinants of the 2 by 2 matrix. Okay, so which is I already find a formula for that, y1, y2 prime. Okay, y1, y2 prime minus y1 prime, y2. Now that is beautiful. Okay, now let's find y1 prime. y1 prime. What does y1 prime mean? That is the derivative of this function with respect to x. So it will differentiate e raised to the power of ax with respect to x. So that's going to give us, a is a constant here, so that's going to give us a e raised to the power of ax. That is beautiful. And then the other one, if it differentiates y prime of 2 with respect to x, so that's going to give you b multiplied by e raised to the power of bx. Now, apply this formula right here. So we have the Wroskian of y1 comma y2. So this is going to be equal to y1, which is e raised to the power of ax. Okay, multiplied by y2 prime, which is multiplied by b, then multiplied by e raised to the power of bx. Then minus y1 prime, which is a, then multiplied by e raised to the power of ax. Then multiplied by y2, which is e raised to the power of bx. All right. So what I think is common here? So what is common is e raised to the power of ax, e raised to the power of bx. So we have e raised to the power of ax, then multiply by e raised to the power of bx, then into b minus a. So we can also apply the law of indices right here. So we apply the law of indices. So we have e raised to the power of ax, then a plus bx, then into b minus a. Now we can see that this is not equal 0. Okay, so since this is not equal 0, so that shows that these functions are linearly independent. Okay, so for the first question, y1 and y2 are linearly independent. Linearly independent. You can see that this is very easy and straightforward. So what you have to know is just the theorem and then know how to find the Wroskian. Then you are good to go. Okay, now the second question, let's quickly do that. So I think I will be clearing this part. All right, the second question, which is y1 equals cos ax, and then we have y2 equals sine ax. So we want to check if these two functions are linearly independent or linearly dependent. Okay, so now let's don't forget the formula. The Wroskian of y1 comma y2 equals I think sorry, I forgot the formula always. That's y1 y2 prime, sorry for that. So y1 y2 prime, so minus y1 prime y2. Beautiful. Okay, now the first thing we're going to do is to find y prime. So y prime, that is, you want to differentiate this with respect to x. So we differentiate cos ax, so that's going to give you negative a sine ax. Then if we differentiate sine ax, so this is going to give us a cos ax, all right? Now let's find the Wroskian. So the Wroskian of y1 comma y2, so this is going to be equal to, so y1, which is cos ax, okay, then I multiply by y2 prime, which is a cos ax, then minus y1 prime, which is negative a sine ax, okay, then I multiply by y2, which is sine ax. Now, beautiful. Negative multiplied by negative give us positive, okay? So cos ax multiplied by cos ax will give us cos square ax, then I multiply by a. So we have a cos square ax, then a plus sine ax multiplied by sine ax, then multiply by a will give us a sine square ax. Okay, so we can factor out a because it's common. So if we do that, we have a then into cos square ax, then plus sine square ax. And then remember that cos square ax plus sine square ax, that's going to give us 1. Okay, then we have a, then multiply by 1, so which is equal to a. So that is beautiful. So since when we find the Wroskian is not equal to 0, that shows that the two functions are also linearly independent. That is also beautiful. So they are linearly independent. So the last question I will be doing, which is the third question. Okay. Guys, please don't forget to subscribe to the channel. Okay, like the video, comment and share. Thanks for doing that. Now, the third question, which is y prime. Y1 equal 1, which is what's it called? A constant function. Okay, then we have y2 equals e raised to the power of ax. So we want to check if these functions are linearly independent or linearly dependent. So Wroskian of y1 comma y2 equals y1 y2 prime minus y1 prime y2. I think I got now. Yeah, let's check. Yeah, I got now. Okay guys, so let's move on. So let's find y1 prime. So we differentiate the constant function that we're going to give us 0. So what about y2 prime? Okay, if we differentiate this is going to give us a multiplied by e raised to the power of ax. Now let's find the Wroskian. So the Wroskian of y1 comma y2. So it's going to give also y1, which is 1, then multiplied by y2 prime, which is a e raised to the power of ax. Then minus y prime, y1 prime, which is 0, multiplied by y2, which is e raised to the power of ax, and that will going to give us 0. So we have a multiplied by e raised to the power of ax. So which is not also equal to 0. So that shows that the two functions are also linearly dependent. All right, guys, so that will be the end of our lecture for today. So I will give you the task to check for IV and V whether they are linearly dependent or linearly independent. All right, guys, so thanks for watching. See you next time. Thank you.